Okay, we'll let people stream in for a while, of course. Usually get started about right on the time or about a minute after. Folks got any questions or anything like that before we get started, feel free to just pipe up. You can also write stuff in chat if you don't feel like talking or you're don't have a mic. Yeah, get going in a bit.
I had a question about the website. I was going through some of the materials on there, and I saw that there's a lot of previous lectures posted on YouTube, I think. Are those of any use to us, or should we just kind of focus on the live ones during the quarter?
So what's going to happen is all of those are going to get updated and replaced with new ones this term. So what I do is I re-record and repost those YouTube videos every single term that I do this, because things get updated a little bit. So they're going to get completely renovated. The ones that'll be recorded starting today using Zoom are just going to get posted right up on YouTube, including the lab. So a lot of my content is pretty consistent across terms. It kind of depends on when stuff gets updated or things break, or I decide I need to procrastinate with my dissertation. I decide to write a new unit on something, which happens. So we'll see kind of where we get. But most of that stuff's pretty up to date. If you want to jump ahead, those lectures are by and large not out of date. And so you can get useful stuff out of them. But this is going to be exactly the same general stuff we'll cover.
Okay, thank you.
Yeah. So in chat there, when should we have all the packages for R installed? So far I only have R in RStudio downloaded. Looks fine to me. So we're going to install over the course of the term a bunch of different stuff. The big one that's going to take a long time to install is when I sort of say, I'm going to tell you to install Tidyverse. We're not actually going to use any Tidyverse stuff today, but starting on, at least I don't think so. No, nothing. Starting on next Wednesday, we're going to start with that, and I'll ask you in that lecture to install it, but you could jump ahead and do it. Install.packages Tidyverse installs an enormous number of packages, like upwards of 100. It takes a while to install, but you could do it during lecture and you wouldn't fall behind. So if you got R in RStudio installed, you're right where you want to be. And if you don't yet, that's also fine. I would recommend you might give it a go now, but if you have any problems with it, you'll let me know and I'll walk you through if you have any problems. It's kind of funny, some of the stuff that can crop up when you try to install R in RStudio and get them running. 95% of the time it works fine, and then every once in a while you have a computer that just is angry about it. That's fine. If that happens, that's what I'm here for. Okay, let's see. Got about 41 in. That's not too bad. Might as well go ahead and get started. It's 3:31. It's not like when I was in lab rooms, you always be like, well, if you're looking for an art class, you're in the right place. People don't tend to walk into the wrong Zoom rooms anymore. But I'm gonna love that when it happens again, back in person someday deep in the future, and people actually can go into the wrong room. Okay, so let's get us moving. So right away, I want to tell you what I view as the point of this course and what I hope you get out of this course. And maybe this will align with what you want. If it doesn't align with what you want, maybe we can talk about that too. So my goals for this, the first one is to do what I call to develop intermediate data management and visualization skills in R. So notice here I say intermediate. I do not say beginner. The goal of this class is to get you sufficiently up to speed that you can independently use these tools, work with them, go do something like be an RA for somebody, go TA for a class that has some technical components. I don't want you to just get like this gentle intro into it that doesn't teach you any real world skills, and then when you get in front of a real data set, be unable to do things. Instead, I'm going to show you the real tools like I use on a daily basis to work with things, and I work with a lot of stuff, and you're going to do homework that will simulate doing real work, because I'm actually going to give you real, sometimes truly hideous data sets to work with. I'm going to give you administrative data. Nobody should work with administrative data, but that's what's going to happen. And you're going to learn the necessary tools to sort of work through that stuff. These are intermediate skills. You can continue to advance for years and years beyond that, but you'll get a pretty fast, rapid rise up the initial learning curve of R. Next, I want you to learn basic programming. So when I say basic programming, I mean learning those fundamental building block skills of programming that apply to all programming languages. These are going to be things like flow control, iterative operations like loops, stuff like that. You're going to sort of accidentally learn a tiny bit of object-oriented programming and some other things like that. It's mostly going to happen kind of passively in the background, except for maybe lecture 6 when we really spend a lot of time on loops. So I'm saying here intermediate data management, but basic programming. The idea here is that, okay, we're going to learn the functional skills necessary to work with actual real world data. And you're also going to learn some of the nuts and bolts stuff that people who do real programming, especially people with like comp sci backgrounds, sort of know and understand, goes on behind the hood and gives you some more powerful tools to work with. We'll teach you some basics there, especially with iterative programming, but we're not going to go super deep into it. And this is very much a class focused on application, applied R, rather than sort of theoretical use. Next one is, because this is just my jam, I'm going to force feed you a lot of stuff on reproducible research practices. So I think that non-reproducible science is bad and people should stop doing it. So we're going to learn some reproducible research practices. You're going to learn it kind of by accident because every homework, every assignment you have in this class is going to have to be turned in as an R Markdown document, which is a form of reproducible research document. Everything you do in this class is going to be it. Turns out it's really easy to do and you don't have any excuse not to do it. So make your research reproducible in the future. Especially in week 10, we're going to finish off with me ranting for a solid 40 minutes about reproducible research. I put it at the end in case you don't want to tolerate it, but we're going to get there. Last sort of component here is I want to prepare you for statistics and CSSS courses. So one of the reasons this class was originally created was because people were coming into CSSS and stats courses sort of underprepared to do the programming necessary in those classes. And that's a training deficit that you can blame on all of your programs and also graduate school in general, that they sort of don't teach you these fundamental things. Instead, they throw you to the wolves, let them ravage you for a while in stats classes and expect you to get some statistical learning out of it at the same time. So that's bad. And we should not do that. Instead, we should have classes like this that teach intro programming, like your first term in graduate school for like everybody. But until we get to that enlightened state, we're stuck with this class. So this class will get you to that level of necessary fluency to not be deathly afraid of and dying from programming in stats classes, so you can instead be deathly afraid of and die to notation and things like that. Okay. So that are sort of my general goals for this class, right? I want to get you up to speed to just sort of operate in this environment and not be terrified of it and overwhelmed all of the time. Just some of the time, and that's okay. You'll get used to that, and that's actually a healthy feeling. So, okay, so who am I? Who's this person who's going to attempt to teach you all of this stuff? So my name is Chuck. I'm not a Dr. Chuck. You can just call me Chuck. Don't give me the undeserved respect. And even if I was Dr. Chuck, I wouldn't make you call me Dr. Chuck. That sounds weird. It's like a kid's dentist. It's Dr. Chuck. No, don't call me that. I'm just an instructor. I am not a professor, so no respect. I am just a long-time sociology PhD student. This is my 7th year. It is my last year ever. This is actually probably my last term in graduate school because I am finally going to become Dr. Chuck. But I've just been in the game a while. I'm a graduate student like you, so treat me like that. And my job here is sort of like collaborate with you and be somebody in a similar situation to you and understand your plights in this rather than somebody who's been removed from it from a long time. My research areas, if you're curious, and if you're not, you're still stuck listening to me. My research areas are generally or broadly quantitative sociology, okay? I do a lot of quantitative work in sort of areas of demography, especially criminology and deviance, but general quant soc. I'm somebody who typically is pretty easy to rope into quant projects of other people because I like doing the stuff I'm working on. I'm involved a little bit in computational social science, and I tend not to think of the work I do as super computational, but it does involve large data sets, sometimes social media data, advanced computational methods, and computational analytical techniques things for working with data sets that are difficult to work with, unpleasant to work with conventional statistical techniques, or where conventional statistical techniques are largely irrelevant because sample sizes are too large and things like that. And lastly, I do a lot of, or have done in the past, a lot of work in experimental crim, field experiments in criminology. So running out into neighborhoods and trying to get people to steal mail and shit like that. So I also do other work that's not sort of purely statistical and quantitative, but I have like a broad range of stuff. So because of my interests being what they are, I've developed a lot of specific and powerful skills in the things that I'm going to be teaching you this term. So to translate that into sort of what I bring to the table or what I'm going to be doing, is I'm somebody who writes code every single day. I'm completely an applied programmer. I spend hours a day writing code, and I work with the sort of data sets many or most of you probably work with. So the sorts of problems you're going to encounter are the things I bash my face against every single day. If you have problems that you run into, I can help you solve those problems. Even if you have things that aren't applied to this class, if you have issues and technical issues while you're in this class or something, shoot me an email, shoot something in the Slack channel. I can make your shit work. So yeah. Next one, I am a gigantic nerd. I am a massive turbo nerd. I spend all my time doing coding. I love coding. I love stats. I love this. Because of that, I like it when you bring me your problems. I find the problems people bring me to be interesting puzzles. You are not bothering me when you write me a long email about some technical thing. Don't feel guilty about shooting me out some email, some Slack channel message. This stuff is entertaining to me, much more entertaining than my own work I'm supposed to be working on. So it sometimes gives me a nice break if somebody shoots me some message. And this also isn't technically limited to anything in this class, nor even while you're enrolled in this class. I routinely have people who were in my class 2 or 3 years ago shoot me some kind of message being like, okay, I really can't figure this thing out. I'm always just like, oh, it's fun. And I will do that. Okay. I'm a nerd. I enjoy it. You're not bothering me. Please, if you get stuck on stuff, ask me for help. I will enjoy helping you with your problem much more than you will enjoy bashing your face against it on your own. Lastly, I think programming is just really incredibly important, and it's something that we are not taught sufficiently in our graduate programs. It's something that is a necessary skill nowadays for working in a modern research environment. Just about everything has some sort of code base to it. It's really easy to do it badly. It's really easy to waste huge amounts of your time doing it inefficiently. Your time is valuable, and doing it correct is important. The fact that these skills are not taught as a necessary component of all of our graduate trajectories is kind of like a local war crime of some kind. Like, it's just bad for science. It's like, in my opinion, just doing damage to the entire field of science. So yeah. Oh, so here's the one I missed there. Is the Slack channel open yet? Yes, it is. I was actually going to introduce and talk about it in a minute, and I'll send out an email today. So sometimes people enroll like today, and I just wait to send out the email so they all get it. Yeah, but you can email Breon too, and he'll take care of it because he's an admin on the Slack channel. So speaking of Breon, Breon is the TA for this class, and he's going to introduce himself here and then tell me when he needs a slide advanced, because I forgot that with bullets and things like that, he's going to have to do that.
Thanks, Chuck. Who am I? Chuck said I'm the TA. My name is Breon. It rhymes with neon. If you call me Brian or Bryant, I will answer to that as well. My name's been messed up my whole life. It's not weird to me. I get it. Hit it, Chuck. I'm a 4th year sociology PhD student. I actually took this class when I was a 1st year. And so a little bit of it makes me feel like it's asking a 5th grader to drive the school bus, but I'm here to help, and I feel like I can do it. Hit it, Chuck. What are my research interests? Substantively, I study labor and collective action in pay-setting institutions, which all bundled up means I study how people stay paid. The way that I do that is through econometrics, counterfactual reasoning, computational data collection. These things are very interesting to me and are like the normal skills that I employ. Although if you do have other questions about other skills, I have sort of dabbled in a lot of demographic methods and Bayesian stats, what have you. I also have like a big interest in reproducible research, even like down to like the data collection stage. I feel like reproducible research has like a broad umbrella. I'm a reproducible from the start kind of person. So if you're still not into that and you think that science can be done without it, I'm maybe not your best friend, but we can still be friends. About me, what's there to know? I also write code every day. I write little memos and things in R. I'm mostly an R person. I do know Python at least a little bit. My SQL is decent, but I write virtually all my code in R. I am a nerd just like Chuck, but only between the hours of 9 and 6. So if you send me an email about your code or the homework, I am there for you between the hours of 9 and 6. After 6, I turn into a geek. And what I do then is I watch sports and I play video games, and I'm not as available. So just keep that in mind. If you send me something after 6, I'll get it to you in the morning. And I do have one thing about me that I think sort of embarrassing, but I think that social science programming is magical. Okay. The reason that is because unlike a lot of like maybe hardcore computer science programming, social science programming is designed to get the job done and be human legible. It's not necessarily trying to optimize all of the things to save the most RAM on your computer or to do all this. That's part I'm not so worried about. The part that I find social science programming to be magical for is that it's about making your graphs look nice and making sure that your collaborators know how you made the graph and that everyone can see all of the steps that you took, which I think is a little bit different than just code that runs like a duck, you know, like all the stuff under the water is like crazy and going real hard, but on top it's floating fine. I think social science programming is a lot like a duck, but the water's clear.
Thanks, Brian. So
No.
I'm real happy to have Brian along for the ride this time. I normally don't have a TA, but I'm prepping Brian to take over this class going forward in the deep future. So I think it's going to be pretty great. I think he's about the right person for that job. So for logistics for this class, the way this class is going to sort of format-wise, you're here, so you know where lecture is. Lecture's in the cloud. So it's on Wednesdays, 3:30 to 5:20 here. I have a recommended but not required lab on Mondays, which I'm going to talk a little bit more later. Basically, we're just going to be sort of jamming with you, working through your coding problems, solving your stuff for your homeworks or for your other stuff, sort of live office hours type thing. We do have proper office hours. Brian has office hours Thursdays, 11 to noon, but also both of us can do by appointment. Materials for this class. This class is a fully reproducible open access class. Every single thing for this class is fully available on the website, and the website's hosted on GitHub. If you want anything you see in this class, you can pull my entire class down as a GitHub repo and see every nut and bolt in the entire thing. It's all open to you. It's there, and it will stay up basically permanently. It's probably not going to get updated very much. My one won't get updated very much going forward because I'm going to be out of teaching for a year or two. But Brian takes it over. He'll probably clone the repo over. It'll keep getting updated on his side. So it's sort of like a perpetual resource. This class is designed to be as minimally stressful experience. It is a no credit class that requires only 60% of the points to get credit. And many of those points are basically freebies. I don't think I've ever had anyone unintentionally get no credit in this class. And I've had many hundreds of students take this class. Okay? So all work in this class centers around homeworks. There are homeworks most weeks. They're 75% of the grade. They're 3 points each. They're a combination, I say, of reading and programming. You'll mostly read some instructions. You'll write a little bit of code. Maybe you'll read a chapter in something, but I'm not going to test you on it. We're all adults and grad students and busy. I trust you to prioritize your time better than I can prioritize your time. So you do you. There's also a peer grading component that is 1 point every week, so 25% of your grade. Both these things are handed in via Canvas, and that is the only thing I use Canvas for. Everything else is up on the public website. So the public website, If you click on it, you can see everything for the classes here. I'm literally lecturing directly off of the website right now. That's what I do. You click on it, you get my slides. There's also other stuff up here, like if you want to follow along the code that's in the slides, there's R scripts, there's PDFs of the slides, there's the code that's used to generate the slides in the first place. My slides for this class are all done in R. Everything is here. There will be YouTube and Zoom links to videos of the lectures. You'll have your homeworks posted here, solutions after that, and then lots of little random resources and links that aren't always the best updated, but usually interesting things I see. It's sort of like a all-in-one link to the rest of the world of programming. You can use it as sort of a launching pad. Okay, so everything's there. So, okay, it is fair to cringe whenever you're in a class and somebody says there's going to be peer grading of anything. I have dropped a class before because it had an extensive sort of peer interaction component, and I generally try to avoid interacting with other people. So the reason there is a peer grading component in this are a couple things that I've got in from other programming classes and software development and stuff. One thing, you will write your reports, that is your homeworks, better knowing other people will see them. Okay, so if you know other people are going to look at it, you might make it just a little bit less awful. This is one of the advantages to like pair coding and team coding in work environments, is you make your stuff a little bit better documented. You pay a little bit more attention to it if you know other people are going to see it because of shame. And that's good. That's a good mechanism. It's useful. The next one, you'll also learn from other people. Sometimes you'll be peer grading paired. You have very little experience and you're terrified of this, which is healthy and that's fine. But the other person over there is a dynamo and they've been doing this for a while. That's great. You'll learn new things from reading their homework. That's cool. It's sort of a nice exchange. Okay. So somebody commented, are the solutions for future homeworks also there? I think I pulled them down, but if you know how Git works, it would not be very hard for you to get the solutions because Git tracks every change ever made to a repository. So every homework solution is there if you look hard enough, but why bother? The whole learning experience is about trying to work through this stuff. And honestly, we're going to work through the homeworks in the lab anyway. So why bother? Okay. So the format. Okay, the format for peer grading, you get a randomly assigned peer. You have an entire week to do your peer grading thing. There's a little rubric here if you're interested, but it's pretty straightforward. The idea really is just leave a few constructive comments, a little bit more than just a good job. On the first 3 assignments of the term, I expect a few sentences, 2 or 3 sentences. Just be like, I like that you did this. Maybe if you consider doing this, or if it's like broken in some way, I think this is what your problem is, that kind of thing. You can write less on assignments 4 and on because they're template-based assignments that we're going to work through in lab. And if they're perfect, you can literally just say, it looks like you were in lab. This looks perfect. It's great. I have no comments. Or you might suggest something else if you want to. But the first 3, put some effort into it. If you have somebody peer grade you and you don't get as much feedback as you want, email us, email Brianna or I, and we will go through your thing with, if you want, a fine-tooth comb commenting on everything. We just don't default to going through every single homework with a fine-tooth comb, because honestly, most people don't need it. I kind of tested it when I first started teaching the class. Most people didn't really seem to care too much, and the people who wanted more feedback would come and ask me anyway. So just ask us. It's a more efficient use of time. It also lets you focus on what you specifically want to know. If you really struggled on one particular thing and you weren't in lab to ask us questions about it, you can be like, can you tell me more about this? And we'll be happy to answer and get into it. Okay. So materials for this class. I already kind of covered that. It's all on the course website. What's on there, right, are the slides, the code used to generate them. In our script, you can follow along with in class if you want to. PDFs, if you'd like to take notes on PDFs. Templates for the homework, starting with homework 4, video recordings, links to other resources. Okay. If you find anything on the website doesn't work, hit the Slack channel or an email. It'll be fixed surprisingly quickly. I don't check these things all regularly. Honestly, I should write a script that checks and makes sure none of the links are broken, but I'm lazy. Okay. Yeah. So here's a question. Are labs drop-in or do you need to show up at 3:30? Drop-in. I'll be there till 5:20. Okay. So let's talk about lab, since you asked, right? So lab is optional. You're not required to show up. It's just strongly recommended, and I will record them for people who've scheduled stuff over it like everything else. Your time is valuable. I'm going to treat your time like it's valuable in this class. Okay. Labs 1 through 3 are sort of general technical support in R answering labs. I will answer things for your homeworks or not for your homeworks. You can come in and work on your homeworks, but those ones aren't template based. So sort of free form, experiment with some stuff type labs. What you can do is sit in there, and as you're working through it, if you want to know how to do something, you ask and we'll walk you through it and help you work through how to like work out these puzzles of stuff you want to do, how to make it all just operate, and also solve common errors that you will inevitably run into. You will always run into errors. No one ever who writes code does not get bugs and errors all the damn time. In fact, the majority of times I try and run a line of code, it breaks. Okay, that's fine, and you'll get used to it. If you've never really done any programming before, that can be sort of a scary thing. You kind of expect, for instance, you know how to write a paper and the sentences don't just leap up and bite you in the face constantly. Coding is not like that, and that's perfectly okay. You learn by spiraling through failure until it suddenly works. Once it works, you move on to the next problem. That's how it all works. Get used to it. It's okay. It'll be this way for the rest of your career. You just get okay with it and realize error messages are not yelling at you. They're not angry with you. They're just trying to give you useful information. They're just really hard to read right now because you're new to this. Anyway, so labs 1 through 3 are kind of free form. Labs 4+, we're going to walk through the homeworks together. We're literally going to do the homeworks beginning to end, every part of them together as a group. It's really going to be us soliciting answers from you line by line of code until we spiral into the answer, but we'll get there, always have managed to get to the end of the homeworks every single time with no problem. So doing it this way gives you nice options. It means if you want, you can work totally independently on the homeworks and learn maximally sort of on your own. If you work best by beating your face against the screen until you learn it, which is how I learned through trauma, but not everyone learns best that way, okay? You can also, if you don't like learning that way, don't even touch your homework until lab. Come in and work through the entire thing yourself. If that's what's most comfortable for you and least stressful and anxiety causing, you can do that. I do recommend, I think it's best to not rely entirely on the lab because you are going to have to eventually do this stuff on your own. But at the beginning, especially, feel free to do that. Mix and match also to your heart's content. And you're not required to show up to labs. Attendance is a ridiculous thing, so we don't do that any kind of thing. You're not graded on it. Show up if you want to talk to us and get help. You're not required. Okay. So this class has a few different ways to get help. So the first way to get help is with a mailing list. There is a standard email list linked off of the website. If you want help on the mailing list, my only request is you don't ask questions like this. I tried LMYX, it didn't work, what do? Okay, please don't send me emails like that. Make them look a little nice. Do something like this. You give me some basic code that lets me replicate the problem, and then you say, running the block of code above gives me the following error. Error in model.frame default, blah, 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 variable lengths differ. For us, we're going to see immediately variable lengths differ for X means that Y and X are a different length, and you can't run a model with different length variables. You change that to a 1, it'll work, or you change that to a 0. I can see that from a mile away. I don't expect you guys to even know what the hell any of this is, but because we've been in the game a long time, if you give us a nice block like this, we'll solve your problem in 5 seconds, okay? This up here is not super informative, and what that's going to get is a snarky response that will still ask for more information. It's perfectly fine. Okay, so something like that, we will solve your problems and we'll solve them fast. Just give us a little bit of stuff to work with. Screenshots also work sometimes, but not always. The best is usually something that's a semi-reproducible piece of code. You can also send the entire RMD file if you're working in a Markdown file. I'll look at it, I'll run it, I will find your problem really fast, okay? So if anyone is in here and they're not presently enrolled and they want to be on the mailing list and I haven't already told them they're on the mailing list, shoot me an email, I'll add you to the mailing list. Okay. The other way to get help in this class is a Slack channel. So Slack is basically, if you're familiar, it's kind of like Discord for programmers and businesses. If you're older school, I don't know what to compare it to. It's like an IRC channel for work if you're old like me. Okay, so a Slack channel is basically a chat room that you can post stuff into. You will receive a link to join the Slack channel at the end of class, or even honestly, Brian might even send it out while I'm sitting here. Perfectly fine if you want to send that out to the mailing list. You'll get that. I recommend the Slack channel for asking questions, especially short questions and rapid fire type questions. The mailing list can be better for long questions or things that require you to attach a file. You can attach a file in Slack if I ask you to. Slack is also nice because you can do a back and forth, and I highly encourage you that if you have some idea how to maybe solve somebody's question, go ahead and respond to people. Also send each other links and things to stuff, useful stuff. Go ahead and chat on. You'll also notice that if you go to the Slack channel for the class, it actually has the accumulated years of chat history of every other person who's taken the class in the past. You can always search around and see if there's any interesting, useful stuff to you up higher up. Okay. Again, if you're not enrolled in Slack or you're not enrolled in the class and want to be on Slack, email us. We'll get you on the Slack channel. Okay. I still have people who took my class like 2 years ago and still send me Slack messages periodically. I'm still paying attention. I am always there. Okay. So next, a quick note on slide formatting to help you navigate the slides in this class. Okay, if I bold something, it is not bolded for no reason. I probably bolded it because it's something I want you to pay attention to. Bold usually indicates a vocabulary term. It's a word I want you to recognize, remember, pay a little bit of attention to. It's probably something important, some general term. If you see a bolded term and I haven't explained it in some way and you're not sure what it is, definitely check in. I may have just brushed over it. I try not to, but sometimes I'm on a roll, as you can tell, and I just kind of keep talking and I miss things, so it happens. Okay, yeah. Italics are sometimes used for emphasis, but they're also used to point out things you have to click with a mouse. If you see something like please click, you'll see in italics, file, print means go to the file menu and press print. Not that we would ever print anything in this class, but in theory, you might do that. Next, you'll sometimes see code in kind of a code font with a slight gray background. This represents R code you would actually type into your editor or your console, or it will also represent keystrokes you could use to perform actions. So you might say something like, again, my obsession with printing continues, press Control P to open the print dialog. That would be Control P or Command P, I guess on a Mac, will open up the print dialog. So I'm highlighting this to indicate it's something you input in some way. Lastly, you'll see stuff that looks like this. These are code chunks. Code chunks that span the whole page represent actual R code that is embedded inside these slides and was run when I generated these slides. So in this case, I typed into the slides 7 times 49. When I ran these slides, I compiled these slides, it also gives me a result because R can do math, it calculates it out. So this is actual R code here. These are the results from that R code. So the 2 pound signs, hashtags for you kids, with the 343 over here are the results from the operation 7 times 49. Okay, this is live code in the slides. We're going to talk about this later. This is that reproducible research thing I talked about. My slides are reproducible research documents. If you embed code in them, it runs the code and produces the results. This is a thing you can use to generate dynamic reports, but also journal articles, slides like this, whatever you want. You can embed code in it. You're going to learn how to do that today. It's a really easy thing. In fact, it's one of the easiest things I'm going to teach, and it will become basically second nature to you within a week or two. Okay. So the lecture plan for this term, we're going to begin today talking about Rstudio and R Markdown files. I'm going to walk you through the Rstudio software platform, the IDE, show you around. Then I'm going to talk to you about R Markdown files, which are, like these lecture slides, ways to weave together code and text into a single file, which generates something nice to look at, but documents your results as you go. We're then going to talk about visualizing data. One thing I do in this class that I think is a good approach to classes like this is I show you the cool stuff first. I get you in with the cool usable stuff. R Markdown, teach you some reproducible research. Go straight into visualizing data with ggplot, modern visualization tools. I'm not teaching you bullshit. You're going to get the stuff I actually use on a day-to-day basis. We're going to go straight then to manipulating and summarizing data, which includes SQL-style joins of data, complex data manipulation stuff. These things, these 3 alone are sufficient to get you really moving in the world of doing basic analytics with data. Then we're going to talk about nuts and bolts, and we're going to kind of sort of spin back, talk about data structures, things like what really are vectors and matrices, data frames and lists. We're going to talk about importing, exporting, and tidying data. I say cleaning data here, but a lot of this is pivoting data around, which is an operation. difficult to wrap your brain around, but once you get through that, you'll find it second nature, and pivoting data becomes a very important operation in your day-to-day life working with real data sets, especially survey data. Then we're going to get into the ugly stuff. And by then, 5 weeks in, you're committed and you're stuck. And so I can do scary stuff and you're probably not going to run away. So we're going to talk about loops, which are ways to do repetitive operations in programming. Turns out people suck at doing the same thing over and over again, so we shouldn't do it. You make computers do stuff over and over again for you. That's what loops are all about. And in fact, that's really what your computer is doing at all times. Every electronic device you have has tons of loops running at all times. That's what makes everything run. You should learn how to run loops. They're universal across languages by and large. It's useful. Then we'll talk about how not to write loops and avoid using them ever again using more sort of advanced R style things. It's good to know about loops, but by and large, you don't need to use them. Instead, you can write your own functions and apply them across like different vectors like columns or rows of your data. Then we're going to get into what I call special topics, but some of them are really useful special topics. The first one, the most important one, is working with text data. This is a class for social scientists, and nowadays, by and large, more than half of my students are usually not in the social sciences anymore because people started to cluster in from different units, but most people work with text data. Text data can be a huge pain to work in if you don't know some super secret tricks. I teach you these super secret tricks, which are generally regular expressions. If you learn a little bit of regular expressions, you can do wizardry with your text data. And the neat thing is regular expressions are mostly the same across every programming language you'll ever learn. You learn them here, you can go use them in Python or Julia or something, you'll be set for, life, okay? Then an odd one you don't normally see in an intro class, I'm going to teach you proper GIS, or Geographic Information Systems methods in R, working with geographical data, including working with simple features geometries. I'm going to teach you how to download census and ACS data and map it using census shape files and stuff like that. Turns out R is a fabulous GIS platform. I do a ton of geospatial analyses. I never leave R to do them. I don't use ARC or QGIS because they're slow and in some ways primitive. I work entirely in R. Turns out it's super easy to do. So I'm going to show you how to do that. Then you get about an hour-long rant about reproducible research from me, and then another hour or so of talking about how to take all the results you get in your statistics classes from all those models that they don't really show you how to properly plot the results, or they show you something terrible ways to plot them, okay? You may have taken certain classes, I'm not going to name, where plotting the result from some of your models takes like 50 or 100 lines of code to get the results out of it. It's a nightmare, it's finicky, nothing can be done multiple times. Okay, I'm going to show you that that's actually bad and it's totally unnecessary. And as it turns out, it's often really easy to plot results from models of all kinds. I'm going to teach you all the stuff I actually use on a daily basis to plot model results, compact, fast, efficient, nice visualization of models, and how to make tables in R. Okay, that'll be the entire class here because we got 10 weeks. Yeah, so you know where we're going. If you got questions about any of those things we're going to cover, email, Slack channel, whatever. Okay, so, okay. So let's talk about R and Rstudio. Okay, the thing that you actually came to this class to learn, we will begin talking about now. So, why R? So if you're in this class, you probably have an idea why you want to learn to program in R. Okay, there's a lot of good reasons. You probably have your own, otherwise you wouldn't be taking this class. I'm still going to evangelize to you because you are a captive audience. So R is a programming language specifically purpose-built for statistical computing. Okay? This is something a little different than packages used for statistics like Stata or SPSS or SAS or Minitab or something like that, right? This is a full-fledged Turing-complete programming language. If you already know something like Stata or SPSS or SAS, why would you want to learn R? Well, I'm glad you asked. So the first thing is R is free. So you don't need a terminal server. You don't got to shell any dough out. Free software is awesome. Paying for licenses sucks. Using terminal servers sucks. We actually have a great terminal server that we have access to for our department. CSD has this glorious terminal server, 192 gigs of RAM, 64 cores. Fantastic. I hate logging into remote servers, so instead I built my own massive desktop machine just so I wouldn't have to log on a terminal server, because working on your own computer feels better. Okay? Don't have to work on somebody else's computer, don't have to buy a license. This is really nice. Next thing, R has a massive community. R has a larger community than any single one of those other statistics or software packages. Way bigger than Stata's community, SPSS, SAS, Minitab, any of those, way larger community. Big communities mean there's tons of support out there, and R has a very friendly community compared to something like Stata. Let me tell you that. I ask a question on the Stata list, a bunch of economists descend from the skies and rip all my flesh off. If I ask a question to like R Twitter or the R community, they're all wonderful and nice, and they're polite people. It's a very different community. I like it a lot. They also write a lot of really good packages. Cutting edge statistical routines tend to come out in R before they come out on other platforms. Machine learning stuff comes out fairly equally across Python and R, but way faster than everything else. Okay, so I was just following a Twitter conversation among econ Twitter people talking about how they just really wish somebody would write a Stata backend for the modern difference in difference estimator package in R. It's the kind of stuff you see. They just can't update these other platforms quickly enough to catch up with the open source free development that exists in R. Cutting edge stuff tends to live in R, but not always. Sometimes some econometric estimators aren't nicely available in R, but R can run Stata if you really wanted to, so you can still call out to do it. One-stop shop. Okay, next one. R can handle basically any data format. I used to have a bet that I asked people that I would like owe them lunch or something if they could find me a non-encrypted data format I could not open in R. Somebody who works at the Canadian Census Bureau sent me a file some ages ago that turned out to be a bizarre database slice file I'd never seen before, and there was no native way to open it in R. So I wrote one in about 10 minutes, and he do not owe him lunch as a result of that, because now it exists. Anyway, you can open basically everything. I've opened formats off of 80 character fixed with tape drive tapes read off of magnetic reel and stuff like that, ancient formats. There's always a way somebody's written it. R is a very good platform for reading in weird shit. Okay. Big one for me, R makes replication really easy. It's a platform that has built into it many reproducible and replication-based methods and tools. If you want to reproduce your research and make it so that people can download your journal article, press one button and replicate all your results, including generating the final paper, R is the place for that. Python is a great place for it too. Okay. So next one, R is a language. It is not just a piece of software. It's not a software package you give commands and tell it to do things. That's this enclosed environment. R is a proper programming language. Literally anything your computer can do, you can make R tell your computer to do that thing. I've used R to generate moving GIF memes. I've used R to process audio files and video files. I've used R to do all kinds of weird stuff. I use it for mapping. I use it, I mean, it balances my checkbook. You know, I use R for literally everything. It's a proper programming language. You can access anything your computer has at its disposal. This means you can do lots of cool stuff. You can do things like scrape social media platforms, grab things off of like web pages. You can automate calling out to other software. If a routine truly doesn't exist in R, I can just tell R to open up Stata in the background, run the routines, spit the data right back to R and output the results. So I don't actually have to open the Stata. Okay, lots of different things doing it. It can speak to everything on your computer. This is really nice. Lastly, if you decide to move to another platform, most of the skills you learn in R will transfer to other languages like Python and Julia. So Python or Julia, they're slightly different languages in their structure. Python in particular has a more fixed structure than R, and in many ways is sort of a better language, better structured language. Yeah, it's much newer. But most of the skills you learn in R will transfer to these other languages nicely too. So if you decide to move on, most of your skills in something like Stata, unless you get to be a really good Mata programmer, most of your Stata skills die when you move away from Stata to a new platform. Most of your R skills will transfer to some other language with no problem. So you don't have as much sort of a sunk cost tying you to a platform like you would with SPSS, SAS, Stata, or Minitab, right? Or god-awful Excel, right? Okay, so that's my evangelizing. So R is the language. RStudio is not the language, okay? RStudio is instead a front end, or what is called in nerd speak, an integrated development environment, or IDE, for R, designed to make working with R easier and thus your life in general made easier. RStudio can do a bunch of things. I'm going to show you some of them in this class, but I'm not going to show you all of them. Things I am going to show you. I'm going to show you how to use RStudio to organize your code, your output, and your plots. You're going to be constantly working on code, visualizing output, generating plots. That's sort of like the basic thing for RStudio. It can also do things like autocomplete your code, highlight your syntax. When we get into RStudio, you'll see that as you start to type things, if you have an object in your environment loaded that has a name that starts with those letters, it will autocomplete it for you if you hit tab. This lets you use long names for things and not have to constantly type it all out. It also highlights syntax, point out errors it thinks it sees in your code, stuff like that make your life a little bit easier. Next, it will help you view data and objects. It has a built-in viewer that kind of looks like Stata's like data viewer, data editor. You can also open up objects in its environment and kind of see what you're working with. A little bit nice. It also enables easy integration of R code into your docs using R Markdown. So R Markdown doesn't require RStudio, but it integrates nicely with RStudio to perform sort of nice functions like let you run code inside your R Markdown document dynamically without removing the text, stuff like that, and let you kind of see what you're going to get. Nowadays, it actually has a what you see is what you get R Markdown editor built in. I haven't actually used that yet myself, but lots of functionality for R Markdown documents. Okay, so it can also do some other stuff, which I'm not going to talk about in this class. It can do things like integrate your RStudio projects with a Git repository and automate sort of version control for your projects. It can run interactive tutorials in the top right pane up there. It actually has the ability through the learner package to do interactive live tutorials built into the platform. RStudio also is not restricted to working in R. RStudio recognizes syntax and is a suitable platform for coding other languages like C++, Python, SQL, HTML, and shell scripting, and can in fact build in like a bash terminal if you like to do shell scripting in RStudio. It can be a one-stop shop for you. It might not be quite as full-featured for these languages as something like Visual Studio, or I don't even know if that's what they're still calling Visual Studio, or some other stuff. It might not be quite as good for Python as like PyCharm, but it's a pretty good all-in-one. A really cool thing in RStudio is you can actually write Python, C++, JavaScript, and R code in the same document and have them all run with each other and talk to each other. That's hard to do on other platforms. Okay. So if you already know some other languages, you can mix and match and do whatever it's easiest. Okay, so I'm going to sell you a little bit on this R Markdown idea. And this whole term is going to involve me selling you harder and harder on R Markdown. So the ability to create these R Markdown files is one of the biggest advantages of R over other platforms. There are similar things in other platforms. Python is a relatively well-developed ecosystem for it in Jupyter Notebooks. They're still called Jupyter Notebooks, I think. Jupyter Notebooks are essentially a literate programming thing. Stata has a very primitive version of this now, and their more recent version, which lets you integrate Stata code with output, but it's crude compared to what you can do in R. All right. So these things are neat. They let you document the analysis you do in your projects, your memos and stuff by combining your written text, your descriptions of what you're doing, with the code and the output from running that code. So you write up a bunch of text, you write some code to maybe run some statistical models, get those outputs, put them into a table. You run it all. It will run the code on the fly, generate the output, put it into the document so everybody can see. But you can see how everything worked from the very beginning of like, it could even be downloading the data, doing all the data cleaning, running the models, and outputting it all one place. If you hand somebody that single document, they can reproduce the entire memo with a single button press if they have the data available. Okay, and it documents the whole thing. Okay, this is reproducible research at its core. So if you can do this, it means you avoid all that stupid time-wasting shit you've probably done in every methods class you've ever had. So one of those things you've probably done, if you've taken a statistics like intro sequence class, I bet you ran a lot of code in Stata or something. You kept copying and pasting tables into your homework. Every time you ran a model, you copied and pasted a table back into that homework. Never do it again. If you need to update something, you fix the code and press knit, and it updates everything in it based on whatever code you've written into it. Never copy and paste again. Okay, so This is also something that's easy for your collaborators to. Actually, on that last note there, if you've written a journal article and you have lots of tables and plots in there, and you suddenly, because of a reviewer, have to change like one thing in it, and then you have to manually enter every coefficient in every table in your article, if you had that happen to you, know that you might never have to do that again and feel relief. Okay, so anyway, it's also easy for your collaborators to understand. If you're collaborating with somebody else and all your stuff is self-documenting because all the code is in the document, you can hand the thing to them with little to no explanation, especially if you've documented the code, and they can tweak things, look at it, interrogate the entire thing. There's no assumptions there because everything you did, every decision and data cleaning can all be documented in there. Okay, this is good, reproducible, and replicable research. Next, you can show as little or as much code as you want. One thing I like to do if I'm generating a journal article or something like that is I don't want to embed all the code visibly to people. I hide all of the code. It still runs in the background, but the document that comes out is just the results and the nice text. It looks like any other journal article. But if I give somebody the document that generated it, it has all the code embedded in it so that somebody can go back through, change it, but it will still spit out something that looks like a pretty nice journal article. Okay. So another thing with R Markdown, you're not limited to putting out like HTML files or something like that. It can make many different types of documents, often with the exact same files simultaneously, like these lecture slides. So you can make PDF documents. If you're in a like a CSSS or stat class and they really want LaTeX formatted PDF documents, that's a default output type for our Markdown documents. You can spit out a PDF doc. They'll look nice. Okay, you can make HTML web pages and reports. I prefer sending people HTML files because everybody's got a browser on their computer or a phone, so everybody can open it. PDF is a stupid format, but a lot of people work with it, so sometimes you got to send PDFs. It can also generate Word and PowerPoint documents if you like to work in those ecosystems. In fact, there's a couple packages out there that can also dynamically digest a Word or PowerPoint document not written in R Markdown into an R Markdown document so you can edit it and then output it back out. Okay. Another thing, presentation slides. All my presentation slides, even if I don't run any code in them, are written in R because it's so fast to put slides together in R Markdown. I just do it all with my nice template that looks like this. PowerPoint sucks. I just do it all like this. And you can do some fancy stuff in here too if you get good at CSS. Okay. So another thing, it does work with LaTeX and also special HTML and cascading style sheets if you want more formatting control or if you want to do stuff with math. If you know a little bit of LaTeX, enough LaTeX to be dangerous but not want to write all your documents in actual LaTeX, you can put LaTeX code right in a R Markdown document and it will render properly into PDF, but it will also render properly into HTML, which is kind of cool using Pandoc. So kind of a neat thing. See, this is fantastic having Brian here. If I miss a question because my other monitor is awkwardly pointed at me, he's on top of it. You have a TA every time. I'm actually moving my monitor right now so I can read these things because I'm catching the sun. Okay. Yeah. Okay, you got it. Okay. Don't have to do nothing. Okay. So we're going to get back to these R Markdown documents shortly, and you're going to use them for this entire course. And I'm going to strongly encourage you to use them all the time going forward. I typically don't work in our Markdown document as my primary place for doing analysis, but I render all of my final documents, tables, outputs, all that stuff using our Markdown. Okay, but you're going to do all your homeworks in them because it's sort of a one-stop shop. Okay, so let's get started with doing some actual code. Finally, managed to get. Can't believe I'm only at 17 slides and I've already burned through an hour of class. This is going well. So anyway, so let's finally get started with RStudio here. Okay. This is something I call slide creep, by the way. It's like you keep teaching a class long enough and you keep adding slides and slides and slides. And finally, like some of your lectures are just way longer than they should be. So I apologize for how fast I will start talking in about 20 minutes. So getting started here. So if you open up RStudio now, go ahead and open up RStudio. I'm going to walk you through the interface here. So I think there's a bit of a delay when I swap over to RStudio, so we'll give it 1 second to make sure it renders fine. Okay, so we've got RStudio up. If you go up here and go File, New File, and RScript, you should have some interface that looks at least vaguely like my interface here. You might have a different theme than I do. I stare at the computer all day and all night, and so I use a dark, like black background like this so my retinas don't burn out. If you want yours to look like mine, you can go to Tools, Global Options, Appearance. I'm using RStudio's Sky theme and an editor theme of Twilight. That's just what I happen to be using. It's not superior to any other option you have. Use whatever you want, okay? But that's what I use on my home computer. Can you increase the font size a bit? Oh, I can do this. Let me just boost it to 175. How's that? We good? Yeah, using my home computer instead of my lab computer is tough because I have like a colossal 4K monitor and I never know what's going to look good at over Zoom. So is this readable? I mean, this isn't readable to begin with, but theoretically the letters can be made out. They're recognizable as like English characters. Okay, excellent. So the other thing I like about teaching a grad class is people actually turn their cameras on. I taught like a 100-person undergrad class, and you got like that one person on camera who like nods, and you're like, I think there's other people there, but I really can't be sure. Grad students are like, look at us. Okay, anyway, so this is the interface for RStudio. So RStudio is set up such that this here in the top left is what I will call and refer to as the editor window. If you want to write R code, you probably want to put it in the editor window. Up here, I might write something like, I'm just going to say Swiss. Swiss is a data set built into R. If I write Swiss, I can run that here. I type Swiss, I hit Control Enter. You'll notice that the results don't appear in this window up on the top left. The top left is for editing code and writing code. You're going to write most of your code there. The console down here in the left, the console is a place that will display the results of running code. You can also write code straight into it. It will do the exact same thing. The difference here is that if I run code up here in the editor window, it stays there. If I write code in the console, it's gone, okay? So I tend to think of the things I write in the console as being disposable code. Don't write anything in the console you might ever want to use again. It's slightly annoying. You can get it back. If you press the up key on your keyboard, it will give you the last command, and you can actually scroll through other commands, you know, all kinds of stuff if you want to, but it's kind of gone. 98% of the code you write should be up here in your editor window, okay? Other panels that are here, in the bottom right here, we have sort of a multi-function area. There's a file browser here that will show you the current directory your R is looking at. You can browse around in files. It will also display plots down here, the currently loaded packages. It will display help files down here. We'll get to all of these things over the course of the term. There's also a viewer for viewing like HTML documents. In the top right is an environment panel. The environment panel shows you any data or objects presently loaded in R. Unlike platforms like Stata, at least I currently still think Stata can only load one data set at a time, R can load an arbitrarily large number of data sets and objects at once, so everything you have loaded is displayed up here in the environment. This also includes functions you've written yourself. This is a function I wrote myself here. There's also some other stuff up here like history, showing every line of code I've typed since I started R. You can see I was actually working on these slides earlier, so there's some code up there from that. Then there's some other stuff we won't show in the class, a connections tab, a GitHub and Git interact, or a Git tab for managing repositories. If you're into a version control, you should be, but I don't teach you in the class. So this is sort of the general interface. You'll notice everything is tabbed. There's a lot of different like options you can browse through. Lots of different things you can do. If you have multiple R documents and Markdown documents and stuff open, you can browse between them up here too. There's also some other functionality I might talk about later in the class, like project management features. RStudio is kind of cool in that it has built-in project management features. If you're jumping between, like, say, a dissertation chapter, like this is one of my dissertation chapters that I'm working on right here, where I just have piles and piles of god-awful code that nobody wants to see. Stuff like that, I can browse, work on my dissertation, stuff like this, and then be like, oh crap, I got to go teach a class today. I press this and it will resume exactly where I left off when I was working on the class. Project management features are really nice, okay? So here's a question in here. A couple questions. Is R Markdown something we have to download separately? No. So typically, if you've installed RStudio, you've got our Markdown, but you might, when you install Tidyverse, it might download our Markdown if you don't have it already. But it, oh, somebody coming through. Okay. So anyway, yeah, no, our Markdown. If you're not sure, you could go up to create a file, our Markdown. If it hollers at you for doing it, you might need to install our Markdown, in which case I'll show you how to install packages later in this lecture. Next one, any recommendations on resources to learn more about Git workflows? Yeah, Happy Git with R by Jenny Bryan probably would be what I'd use for the RStudio workflow for that. Jenny Bryan is the fucking boss in the R world, so just use her stuff. Yeah. This class is actually distantly related to Jenny Bryan's Stat 545 class through a few different hand changes. So yeah. Anyway, so this is the RStudio interface. If you get questions about the interface or anything, hit us up, let us know. Happy to walk you through stuff. Okay. So anyway, lots of things you can do. You can refer back to this. And remember something about this class that I want to highlight. This class is like a fire hose, okay? There's a massive amount of information constantly coming at you. Do not attempt to stand in front of a fire hose and open your mouth. You take small sips from it as you go, but know you can go back to all these resources whenever you need them. So we move through them kind of quickly and you can return to it. Nobody actually memorizes everything like in coding world. Instead, we look up stuff all the time. We learn how to navigate help files and things like that. Same thing. I actually routinely forget how to do certain operations, and I look up in my own slides how to do stuff. I literally like wrote the slides on it. I forget it. I look it up, especially geospatial stuff. I probably refer to my own slides like once a week to do geospatial operations. It's fun. The materials are here. Okay. So next. If you got that script file open in RStudio, there's a lot of different ways you could run code in that file or generally in RStudio. Okay. So one thing you could do to run some code, you could highlight lines in that editor window in the top left and click run at the top. Or while you have those lines highlighted, click Control Enter, or if you're on a Mac, Command Enter, and it will run all the lines you highlighted. So just run whatever code you have selected. It's one way to run. Another thing you can do is you can put your caret on a particular line you want to run. Caret is not a vegetable in the computer programming context. Caret is the little vertical bar blinking cursor in your RStudio. Programmers call it a caret. In some other languages, some other places, the caret will instead be sort of an exponential sign, but it's a caret in RStudio and in R. Okay? If you put that little caret on a line you want to run anywhere on the line and hit Control Enter, it will run all the code on that line. Your caret will then move to the next line. If you want to rapidly run a lot of code, you can put your caret on the line you want to start on and just hold down Control and keep hitting return. And it will just keep running lines sequentially until it gets all the way there. And when I say a line of code might not be just a single line. It will run all the code that's part of one particular command. If you have a command that runs across multiple lines in your editor, it will run all of them to get to the end of like a parenthesis or whatever. You'll get experience with this as you go. Don't worry too much about it now. These things you'll build intuitively before you understand the technical reasons for it. The learning curve with R is actually sort of like initial terror. Things start to make sense and become intuitive, and then you start to think too deeply about them and they become terrifying again, and you go back up again, and then you keep going through that sine wave for the rest of your life. You just get deeper and deeper questions that come up and you're like suddenly have existential crises. Anyway, that's fine. This is a normal process of life and programming. Anyway, so another thing you can do, you can type individual lines of code into the console down in the bottom left and hit enter. It will run whatever you type in, but it will be lost forever, basically. Most code you'll type in the top left with some certain exceptions like installing packages I'll talk about. Another thing you can do, if you're in an R Markdown document, which we'll get to, you can click somewhere within a code chunk and then click the green arrow and it will run the entire code chunk. So if you have a whole bunch of code in there, it'll run all the code inside. You can also, there's a button on these documents that will run all prior chunks. I'll show these as we go later on. Okay. So regardless of how you run the code, except for the last one in our Markdown documents, it will just show the results of your code you ran in the console. If you save the results of that code to an object, it might show nothing at all because it trapped the output from those functions and stored them somewhere. We'll see this as we go. Okay. So something to know. If you mess up while you're writing your code, biggest ones like leaving off a parenthesis or something, you might see something that looks like this. You might see the beginning of a line indicating some code you started typing. Here's a parenthesis, 11 minus 2. If I run this line, you're not going to get any output. You're going to see a plus. This is R's way of saying, I'm expecting something else because you opened a parenthesis and you didn't close it. And I know how like order of operations works. I'm waiting for that other parenthesis. If you did a closed parenthesis, it would finish and it would give you the number 9, the result of this operation. If you run some code and you get a result like this where you have that hanging plus, but you have no idea why because you ran a lot of code in a go, you can hit escape a couple times and it will cancel whatever was currently running. And then you can go look up there and try and find your missing parenthesis or something. So this just indicates some incomplete code. Okay. Commonly, it's a missing parenthesis. Okay. So R is a calculator. Now, you might be shocked to learn that a statistical programming platform can successfully add numbers. We can test this, though, if we're not confident it's true. So in your console, you might type, follow along if you got it open, might type 123 plus 456 plus 789 and hit enter. If you do this yourself and you attempt to add these numbers far too large for any human to add themselves, you should get a result like this. 123 plus 456 plus 789 ought to be the number 1,368. Okay? You can punch in normal math into R like this, multiple operations sequentially. It will run that code. It will generate a result. It will also follow proper order of operations. If you have a multiplication and addition in the same line, it will do the multiplication or division first, and then it will do the addition. Okay? So the output you'll see in your console is probably preceded by a little 1 in brackets like this. This is the index of your output. This is the numeric index or the entry number of the first thing displayed on that line. Running an addition operation like this only produces one thing as an output. So you get to see 1,368 is the first element of output. If it had output many more elements of things, you would see another line and it would increment to whatever the index is of the first thing on the next line. So question in chat. For R operators, is it still considered good practice, like in Python, for a white space in front and behind the operator, like 1 plus 2 instead of 1 plus 2? It's generally considered good style. It doesn't matter. White space means nothing in R, unlike in Python, but it's considered good style to space them out. I generally try and obey a good style on these slides, but sometimes for compression, like for reasons of not being able to fit them, I'll squish it. But I recommend generally space stuff out, make it look nice and clean. But you do you. The style is in your hands. So now, if you're in your blank R document, in your editor, try typing a line like this. Type sqrt up in your editor, open parenthesis, 400, close parenthesis. Then either click run at the top, or I would recommend control enter or command enter and see what it does. Okay? You should see, as a result of doing this, something like this. sqrt 400 gives me 20. So as you might be able to guess from a combination of the result and the name of this thing we just did, this thing, sqrt, gets the square root of numbers you put inside of it. Okay? So the square root of 400 is 20. I'm going to talk about what things like this are. Okay. So square root there that you just used is an example of a function in R. So functions do just about everything you want to do in R. If you see something like that, some object with some parentheses, usually they'll have parentheses, but not always. If you see something like that and you want to know what it does, you can use help files. If I pop open Rstudio like this, I'm assuming it takes a little while to transfer over, you can get help files in R by doing question mark and then type the name of the function. So I do question mark sqrt. In your viewer pane or in your little viewer area down here, it's going to open up a help file. Okay. I have chosen square root as the example function to get a help file on because it is not a very good help file. This is a help file for a base R function, and base R functions often have documentation meant for people using R in the 1990s who know how to read all of this stuff, okay? So this help file pops up says, oh, well, first of all, it's not even the help file for square root. It's the help file for something called math fun. Math isn't fun. You've already lied to me. Math fun in base. Miscellaneous mathematical functions, okay? So this help file is a help file shared across multiple functions. Specifically, it's shared across the absolute value function and the square root function. This help file tells us the absolute value function computes absolute values of x, square root computes the principal square root of x, that is root x, like this, okay? So this tells us some information about how functions work. These help files are very difficult to read for new R users, but over time, you'll slowly develop the intuition of how to read these things. It's fun. In fact, I have a resource, I think, linked off of the course website on how to read these by Kieran Healy. Help files, you can learn to navigate them. They're tough at the beginning, but it's a useful skill to develop over time. So this says here, the usage of the function. Usage here says how you would use the function in actual application. These are very easy functions, so it just says, you would say absolute value of x or square root of x. Arguments says, what are the things I can give this function to make it do stuff? These functions take just x. What is x? X is any numeric or complex vector or array. Okay, this is a complex way of saying it'll take any bunch of numbers. It'll take any single number or a bunch of numbers in a row, and it will compute square roots or absolute values of all the numbers you give it. That is what a vector is a series of numbers. Arrays are more complicated. They're like matrices and stuff. It's just a bunch of numbers. Okay. Then there's other stuff that can sometimes be really intimidating, a lot of these functions. Like, what does this is an internal generic primitive function mean? If you've been in R for years, this makes perfect sense. It's fine that it doesn't make sense to you. In fact, it's probably useless. Okay. More importantly is all the way at the bottom are examples for how to use the function. So what you can do is you can go and grab the code down here. You can literally copy and paste all that into like an R script and run their example code, and it will show you an example of how these functions work. And then what you can do is take that example code and change it to do what you want. So if you don't know exactly how to make the thing work, steal their code and modify it. This is how programming actually works, okay? You'll go on to Stack Overflow and find somebody else's answer to a question. You'll modify it for your purposes. The help file examples, same thing. They work always. They're designed that they must work to appear in the help file, so you can steal the code and modify it for your purposes, okay? So there is some useful stuff in help files. The longer you spend in R, the more the other stuff will make sense. For statistical methods too, there'll often be the reference of where the statistical method originates from, which can be nice if you're writing a paper on something. You can actually get like the journal article citation. Also, if you say like citation and then a package like, let's go fixest, this will actually give a bibtech entry you could give to Zotero or something if you want to add citation entries for statistical methods used in any of your R packages. So fixest is a good efficient estimation of maximum likelihood fixed effects models. This is something I use as a package for fixed effects. This is the journal article or the discussion paper it's from. This is the bibtech entry. Every R package has this. Never got to wonder how to cite something. Cite your software. It's good for open source developers. Okay, so that's help files. Over time, you'll learn how to navigate them, and in labs, we'll probably walk through some of them. Okay, back to functions. So here's a question. What's the difference between an R notebook and an R script? R scripts are just for writing code in them. R notebooks are a type of R Markdown document that let you weave text together with R code side by side. So they're kind of like a standard R Markdown document. They just interface with RStudio a little bit differently. In this class, we'll use basically R scripts and normal R Markdown docs. You could use notebooks for your R Markdown docs, and it'll work exactly the same way. R notebooks are the same thing as like a Jupyter notebook in Python, basically. Okay, so functions. We're going to see a lot of functions in this class. Okay, so let's get into more R code. Let's talk about creating objects. In R, everything in R is stored as an object. This includes the data, the functions you run, models, the output from everything you run. It's all objects in R. So if you say something is an object in R, it's not very informative. It's just a thing that exists in R. If you want to create an object in R of any kind, you use the assignment operator. The assignment operator is a less than sign and a dash or a hyphen. It looks like a little arrow pointing to the left. There's also one that points to the right. Okay, so you can create an object like this. Let's say I want to make an object that I want to call new.object. What is new.object going to be? I'm going to assign to new.object the number 144. So the little arrow looks like I'm taking 144 and pointing it into this thing. That's how you can think about assignment. I'm taking this, I'm stuffing it in here. Okay. So operators like this are functions that look like symbols. They're functions, though. They tend to sit between their arguments instead of having their arguments in parentheses like square root I showed you on that prior slide. You can actually use operators in R like a normal function by doing something like I could do backtick plus backtick x, y, and the result will be the result of adding x to y. Almost never a reason to do this, but you can if you want, just to know about it. So this is an operator here. Okay. So we do math with operators all the time. When you say x plus y, you're actually running the plus function on x and y. Plus is the addition operator. You've been using operators since kindergarten, so they're not really anything too magical. They're just a way to perform some operation on a couple things. When you add 1 plus 1, you're using 1 and 1 as two arguments to a function. It's just a function we just take for granted as a mathematical operation that we can generally do in our heads. But it's an operator. In R, it's a type of function. Okay. So if you've made an object or you got an object in R, you can display the contents or display that object by calling on it. Calling on an object just means using its name. So if you say new.object, what's going to pop out is 144. The reason for this is on that last slide, I created an object called new.object. I stuffed 144 in it. This means new.object literally is the number 144. If you assign something to an object, it is the thing you assign to it. This is not exactly storing that thing. It's not pointing to it. This has become the number 144. Here's a question. Is it bad form to use equal signs instead of that operator? Yeah. So people will often interchangeably use equal signs in the assignment operator. It works in 99.9% of cases. That 0.1% of cases, it will cause something catastrophic. So one of the rare things that causes a problem is when you do assignment as an argument to a function, it will treat the equals in the assignment operator differently and cause weird errors. I highly recommend using the assignment operator instead of equals. Other people who program in R will disagree with me, faculty and other ones. They're objectively wrong if you actually go and look at what the R people say who made the language about assignment, but they can do that if you want. Maybe their code will eventually have small errors because of it. Anyway, so use equals if you want. It will just cause weird things very rarely. Okay. So in R, you can name things just about anything you want. Names can contain underscores and periods, but your only restriction is they cannot begin with numbers. They can have numbers in them, they just can't start with them. Aren't many other restrictions. And there are ways to make them start with numbers if you're insistent and you just want to be that way, okay? So be consistent with naming objects, okay? Rstudio has autocomplete functions. This means long names are better than vague ones. Do not name every variable in your data set V1 through V72880, because you're going to get V96 and V97 confused and write a bad paper someday in your life. Give them proper long variable names, head off that stuff to begin with. There's almost no limit to the length of a variable name, and autocomplete means you don't even have to have trouble typing it. Good names will save you confusion later. It's ambiguous what a good name is, but within the scope of a project, you'll be able to figure it out. Okay, let's use objects. So an object's name, like new.object, represents the information used to construct that object. This means you can treat the object's name as if it were whatever you assigned to it. They're interchangeable. I can do something like new.object plus 10, and I get 144 plus 10, because new.object is 144. I can add it to its get 288 because it is the number 44. I can get the square root of new.object and get a nice 12 because I picked perfect squares on purpose. It is the number 144. You can use it exactly that way. Okay. If you've assigned something to it, you just use it like the thing you stored in it. Okay. So let's talk about more complex objects. You can see I've already sped up talking. I'm somehow only at slide 25 in a 54 slide lecture, and we have 30 minutes left. Anyway, so creating vectors. A vector is a series of elements such as numbers. R is a vector-based language, so almost everything you work with in R is going to be a vector instead of a single number. Vectors are very useful. So you can create a vector and store it as an object the same way I just created new.object as 144. But to tell R you want to make a vector, you're going to use a function called combine or concatenate. It is a lowercase c and some parentheses. Notice I said lowercase c. R is a case language. Upper is not the same as lowercase. Just know that. I say when in doubt, just lowercase your entire life. Deal with it. Anyway, so combine things together into a vector C. Okay, this is how you do it. So we might say new.object. We're going to assign to that the combination or 16, 25, 6. If I then display .object, it is the numbers 9, 16, 25, and 6. This is a vector of length 5. It has 5 elements in it. They're the numbers I assign to it. This would be how you'd manually generate a vector. You're going to have things generate a vector by performing in math, but if you want to make them yourself, you combine. Okay. So this is important to know about R. Notice how I .object equals that. We already had a new.object. R will not kick a warning message if you overwrite something. R trusts that you know what you're doing, and R is a destructive language. If you attempt to overwrite something, it will destroy it entirely and replace it with a new thing. It cares not for the feelings of the objects. It will destroy them all. So know this with R. Using distinct names is really important because you might destroy things of value. Okay? If you want to keep something, give it a distinctive name. Don't just name everything X and Y and Z because you'll have a tendency to destroy X and Y and Z. But that's fine. You can recreate them. Good reproducibility is about making it so you don't care about anything you have loaded because you can regenerate it on the fly. Okay, so we overwrite it. We have a new.object. Okay, the cool thing in R is you can give a vector like this as an argument to just about every operation in R. You don't have to make it do one number at a time. It can do all the numbers simultaneously. This is the advantage of vectorization that does not exist in some other programming languages. What do I mean by this? Well, if I say square root object, it will take the square of all of the numbers usually of the vector I give it. Gives me 2, 3, 4, 5, 6 to this order of perfect numbers. This is vector that I don't have to specifically say give me this, give me the square root of this, give me this. I can give it all the arbitrary number. I could have given it 10 million numbers and it would have basically instantaneously calculated their square roots and given me an output of 10 million square roots. R cares not for the length of these things up to the your memory. Okay, and it does it fast. So if you're used to other languages over operations like R does not like that. R just background fast for you like. Okay, and as we'll see as we go, almost everything in R this way, functions tend to like take a whole sequence of numbers instead of one at a time. Okay. And of course, stop me if anything. Oh, am I breaking up a little bit? Okay. CenturyLink has been having some odd issues in Seattle, and unfortunately, beholden to the internet connection. It's stable for me here, but I can't guarantee that that is actually the case. I obviously can't go and restart my hardware, otherwise we would lose a precious 5 minutes of my lecture. So hopefully it will stabilize a little bit, but 1 second, I got an idea. Okay, am I still online? Good. Okay, let's see if that stabilizes it slightly. So let me know, is it a little bit better? A little bit? Okay. So I think it may have actually been connected to my Wi-Fi extender in the living room, which somehow manages to overpower the router that's right there from across the house. And that was probably good. Anyway, so hopefully it's better. So anyway, vectors. We're going to spend a lot of time this term working with vectors. They're important and good to know about, but we'll spend a lot of time with them on week 4. So don't worry too much about the nuts and bolts. Okay. So more complex objects. These same basic principles for creating objects apply to everything else in R. There's many more complex objects, things like matrices, arrays, lists, and data frames. Data frames are a type of list which looks like a matrix, it looks like a spreadsheet, but they're lying to you and they're actually a list. We'll talk about this in week 4, but basically it looks like a spreadsheet. Most data we work with in R is going to be read in and stored as a data frame. This course is basically focused almost entirely on working with data frame objects, and the Tidyverse is a platform for working with primarily data frames as objects. Okay? If your data are in a flat file spreadsheet, you're going to read it as a data frame and work with it that way. Flat files are the easiest way to work with stuff. It's all going to be data frames. We will work up on these things continuously throughout the term, but just know there's many different types of objects. You're going to learn all about them over the term. Before we get into these, though, I want to zip back to R Markdown for a bit to give you what you need to know for like homeworks. So let's talk about R Markdown. Okay, let's make an R Markdown file. So in your RStudio, go up to File in the top left, New File, and R Markdown, probably period, period, period. It's going to pop open a little window, and there I want you to just select HTML output. It's probably selected that way by default. And click OK. If you want, you could change the other entries there, but for now, it's perfectly fine. We can save this file somewhere then. You may, once it's open, you might hit Control S, and it will pop in, or Command S, and it will go to a save window. Save it literally anywhere. If you're all prepared and you have a folder for this class, save it there. Otherwise, feel free to save it in Documents or wherever your default is. Save it, maybe, it doesn't have to be this, but a good name might be My First RMD, or maybe My Second RMD if you got a head start before class. And then go ahead and click the knit button. So while you're doing that, I'm going to really quickly do it myself. Okay, let's just. Okay. If you knit a document, you should get something that looks like this, maybe with your own name. Maybe not if you're stalking me and you use my name on your computer. So you might get something that looks like this. It'll say something like maybe untitled or title. R Markdown, this is an R Markdown document. It gives you some information on it. You'll see in the original document we were working in, there were these chunks here of code. They said things like summary cars. But in the document that knits, you see the code here, but you also see what would happen had you run that code in your R console on your own. This is how R Markdown documents work. You can write all this text yourself with headers and things like that, but then you can also write these little chunks and insert R code. Any R code in them will run when you press that knit button at the top, and the output from it will be displayed in your document. And it can include things like plots, right? If you make a plot down here with code like this in the document, it will embed the actual plot. And there's options in these chunks. This option here, it says this is R pressure. This is the name of the chunk as pressure, comma, echo equals false. Echo equals false says don't show people the chunk. Hide it entirely, but still show its results. So it hides the code for it, but does display the plot. This is the magic of R Markdown. So here's something. Required package cannot be found. CA Tools 1.14. So that's a good question. You might try, literally, install.packages, CA Tools, and run that. It should install CA Tools and then try again. This is, anytime you see that error message, cannot find this package, type in the name of it that way. And again, notice I had to quote the name of the package. This is because you're actually giving it a search term to go out and look on a repository and download it. If you're used to Python, R has a far better package management backend than any Python like Anaconda or anything like that. You can trust it's going to do a good job when you tell it to go grab something. You don't have to like fuck around with pip and conda and have them break and make you cry over them. Anyway, okay, so not saying anything within the code within the name and date. So if you want to change the name and date is all up here in the YAML. So make sure you're not in a script file, but you are indeed in an R Markdown file, and you should have a YAML header up here at the top. If you're in a script file, you ain't gonna see nothing. Yeah. Okay, so if you open up an R Markdown file like that, also another thing to note, if you want to view it in a browser instead, there's an open in browser button at the top of the rendered document. It will just crack it open in Chrome or whatever your default browser is, and you can view it that way. They're just an HTML document. It's a web page. Okay. Anyway, so that is an R Markdown doc. They are really, really easy and really, really powerful. So the thing up at the top I just mentioned, that YAML header, there's a thing up at the top. That YAML header, which stands for YAML ain't markup language, because nerds like recursive acronyms, that YAML header up there is its own little language, YAML, which you can use to modify how the document works. Everything else in there is just stuff you can type in normally or write code. Okay. This is that YAML header. For example, this is what it was when I created this slide back in March 2018. It looked like this. You have a title, you have an author, a date, and you can modify these things. This just changes the title at the top of the doc. This changes that author entry. This changes the display date. This here is something different, and notice how it's not quoted. This is actually technically a function call that says I want to render it as an HTML doc. If you instead wrote PDF doc here and knit it, if you have a LaTeX installation on your computer, it would render a PDF document instead. That's how you can change formats quickly. Okay, I'm not going to cover PDF rendering in this class, but I will help you install and set it up in lab if you want. Okay, if you want to mess with global formatting for an R Markdown doc, you can modify stuff up in the header. Here's an example of something you might want to do. If I say in output, I say output HTML doc theme readable like this, it will change the entire theme of the document. It has different fonts everywhere, different sort of text sizes and stuff like that. So these things are themable, kind of the way like a web page, if you have a web page builder, is themable. You can download different themes. You can write your own themes, stuff like that. With PDF documents, you can actually get themes for specific journals you might publish in and render in their exact format. Okay? There's a lot of options for doing stuff like this. My course website you're looking at is just a particular theme I have on a bunch of Markdown documents. Everything can be done with these sort of like powerful tools. Okay, not going to dwell on that, but there's a lot of options. There's a bunch of stuff linked off of the course website if you want to know more about theming your R Markdown documents. One important thing, the YAML header up at the top is the only thing in R that's space sensitive. You have to have your indentation correct. These are 2 spaces per indented line. Anything else in YAML gets angry at you because it's a stupid language. Okay, anyway, keep going. So R Markdown is neat. R Markdown lets you do some basic formatting in your documents to make them look nice, but it doesn't let you do so much formatting that you can waste your time tweaking formatting like you do in a Word document instead of writing your paper because you're procrastinating. Instead, you can just do little bits of stuff like this. So on the left is what you would see in the document. On the right is the syntax you would write to get it. If you want something bolded, you put a couple asterisks on both sides of it. It ends up bold. That's how I make all the bold in my slides. If you put a single asterisk on the side of things, it ends up italic. If you put a single pound sign in front of something, the space is important here. Pound sign space, you get a big header. 2 of them gives you a subheader. 3 of them gets you a sub-subheader. More pound signs makes it smaller and smaller. So you can do headers, okay? You can also do block quotes with greater than signs with a space after them, makes block quotes. Basic formatting, nothing too complex, but just enough to like make sections in your documents. Other things you can do. So here, is there a way to get the code and output from editor into R Markdown instead of a copying and pasting code? I mean, the fastest is probably to copy and paste it. Normally what I would do is, there's actually is a way, I forget, there's some sort of a command that lets you take a R script file and render it as an R Markdown. It's easier to do it the other way, to render an R Markdown as a script file. There's some shortcut way, but I don't remember offhand. I never have to do it. Yeah, I use just copy and paste because it's fast. Okay. My slides, though, like generate a PDF, HTML, and an R script simultaneously, but I just have a function that does that for me, which I could show if people are interested on another day. Anyway, other R Markdown syntax. It handles lists for you, and in fact, it handles numbering them. So if you want to make ordered lists like 1, 2, indented 1, 2, you literally can just do 1 dot whatever your entry is for all of them. It will take care of numbering. You can manually number them too, but it will show up with numbering done for you if you want. So it figures out that. You can also do unordered lists. So instead of 2 asterisks like italics, a single asterisk with a space will give you a bulleted list. A plus sign with a space will give you a open dot bulleted list. So you can do little bits of lists and stuff. You can also embed URLs. A URL is just some text with square brackets around it, then some parentheses and the URL you want it to link to. This is an active link. You can click on it. Links also work in PDF documents too, whatever you make. You can also embed pictures. For a picture, it's an exclamation point, some square brackets. You can leave the square brackets empty for a picture. And then you would link to the location of the image. This here is me actually grabbing the image directly off of some UW site and sticking it into the slides. Yeah. Here's a question. Do you have to code in the editor for stuff, or you can do it all in the R Markdown? Oh, you can do it all in the R Markdown. You can write code live in the R Markdown, run it just like it was in a script. For memos, I just work entirely in an R Markdown. Way to render an R Markdown, R script to R Markdown, Control-Command-Shift-K. Yeah, that makes sense. Yeah. There's a lot of shortcuts to do crazy stuff. I don't know any of them. Okay. So, other things. Cool thing with R Markdown, you can put some math all up in there using LaTeX. If you know a little bit of LaTeX and you want to make pretty equations, you can do stuff like put in equations, fractions. Here's the formula for the mean, right? This is just a little bit of LaTeX code. If you know LaTeX, you can do it. My strong recommendation is you don't learn LaTeX for anything except making math, because it is a terrible language that will destroy your life. But it's really useful for making math, okay? If you want to make code-looking font, you put some backticks around it. Backticks are an important character in R. If you look on your keyboard, the backtick is the thing to the left of the 1 key above the tab and below the escape. Zoom in there, that is the backtick. You use them a lot in R. It's one of those things you probably never had to use outside of here. You use them for doing things, not just in R Markdown, but all the time. When I say backtick, I mean that thing. I'll point it out a couple more times over the course of the term. If you want to have a block of code, like a whole bunch of lines that look like code font, you can do 3 backticks in a row, write some stuff in between them. Everything in between those 3 backticks will look like code. Okay? So it has some minor formatting options in R Markdown, but it's relatively simple. Okay, so you can modify them in lots of ways. I recommend, if you're interested in that, follow links. Other people have written this stuff up far better than me, especially like R Markdown, the definitive guide, which is the R Markdown textbook. You can go and look at this stuff and go wild with it. If you run into problems with it, do let me know. I can usually troubleshoot them. I have a lot of weird Markdown experience, mostly from this class. Yeah, I can help you. These things are all up on the website too. So if you want them, go look at them. Okay, some caveats about formatting. Markdown is designed to be very simple so that you don't spend much time formatting. You instead let background theme documents handle all the fancy formatting, like templates and stuff. If you want to make documents that are more finicky in their styling, the best way to do it is to have templates that take care of that for you in the background. Other things you can do are you could write in HTML and use CSS for custom formatting if your output is HTML format. Or if you're using RMD files or RNWs, you could write LaTeX. If you want to write in pure LaTeX because you're one of those people, you can use .RNW files instead of .RMD. They're like a Markdown file, but 100% written in LaTeX. It's what preceded RMD files. Okay, again, with LaTeX, Here be dragons. LaTeX is a very powerful thing, but it could destroy your life. So I recommend not learning it. But if you really want to go wild with it, or you work in publishing, maybe you'll need some LaTeX. Okay. For most things, default R Markdown is a PDF or an HTML file. Looks great for almost all purposes with no additional formatting. It's generally what I recommend doing. Yeah, these slides are an exception. They're finicky, but these slides are written in a very different way from the RMDs you read in your classes. If you open up my slides, you'll see some weird stuff in there. If you're curious about how it works, ask me. Okay. So let's put some R code into this R Markdown. Inside an R Markdown file, the lines of code you can run are called chunks. Code is sandwiched in these chunks between a series of 3 backticks, a squiggly bracket, an R, another squiggly bracket, all the code you want to write, and then 3 more backticks. You can insert a chunk into an R Markdown document without manually typing all that stuff with I believe, it's either Control-Alt-R or Control-Shift-R. I forget which one it is. You can press that, it will insert a chunk for you, so you don't got to go type all those backticks. Okay. If you write this in your R Markdown document, a chunk with summary cars in it, and you knit it, in your output document, you'll see something like this: the code summary cars, and then the output from having run summary cars. Summary run on a data frame. Cars is a built-in data frame in R. Summary run on a data frame gives you some basic summary statistics: minimums, quartiles, means, maximum for every variable in a data set. It just runs the code, automatically sticks in the document. It's I, not R. Chuck forgets things. Okay, so that's a chunk. Chunks have lots of options. I'm not going to dwell on these, but basically you can customize how chunks look in a million different ways. If you want the output to be displayed, but the code not, you can say echo equals false. If you want the code to show, but you don't want it to run and display any output, you can say eval equals false. If you want to hide the output and the code, yet still run it, you can do include equals false. There's a bunch of things like this. If you have something that takes a really long time to run, cache true will save the results of it the first time it runs. The next time you knit your document, it will use the saved copy. There's stuff like this. You can also in chunk options modify how images come out. There's a million of these. There's just an enormous number of options. I'm not going to detail them. It's better to be in lab and ask me how to do something, and I'll walk you through how to do it. Yeah, there's a million of them. I'm not even going to go to the list. It's horrifying. The common ones you'll want to use are like these first 3, really. Use these all the time. So for instance, if you were doing a journal article with embedded code everywhere and you don't want people to see all the code, you just want them to see the output in the article, you would just end up doing echo equals false on almost everything, and probably where you load your packages and data, include equals false would hide it. And that would be everything you need to do. Okay. So playing with these options, things I'd recommend to do in your homework is mess with these things. You'll see what your homework is in a bit. It's going to be real easy, but mess with some chunk options. See what happens when you take that chunk we wrote before, maybe give it a name. The thing that comes out, if you do R space, this will be a name for your chunk. I'll show you in lab why these names are useful. They make it quicker to browse your documents. Then echo equals false. This will hide the code, but still run it. You'll get that summary table from before, but you won't be able to see summary cars. That's an example. Play with these things in your R Markdown doc, see what they do. That's the best way you'll learn it. Don't try and memorize some list from me. Toy with them and see what they do. Okay. Another cool thing you can do, you don't have to put your code in a chunk. You can put it anywhere you want in the middle of text too. This is something called an inline R code or inline syntax. So if I write something like this in an R Markdown document, 407 years ago is the same as backtick R space 4 times 20 plus 7 backtick years. When you knit this document, you're going to see this instead. 407 years ago is the same as 87 years. What it's going to do is it's going to go run any R code that happens after this R space, get the result of it, and put the result in the middle of the text. So, you know what this can do? If you've run a bunch of models in your paper and you want to refer to things like point estimates and confidence intervals, standard deviations, any of that kind of stuff, you don't have to hard write that in. You just have it call back to the model or things you've calculated in it. And then if you update your data set or something, all the text in the document will update for you. Okay. This can be real powerful. You can make documents that fully update every time you knit the document, maybe by downloading new data or something. You can have it all update on the fly. You just modify it with Inline R Code. I'm going to make you do 1 or 2 of these on your homework assignment. Play with it, see what happens. Yeah, it is pretty cool. You can go real wild with it too. Okay, so here's an example. Maybe we've saved a variable in a chunk. We want to reference it in the text. I say here, I'm going to assign to x the square root of 77. Again, this is the assignment operator. It takes the thing on the right and puts it in the thing on the left. I can then say the value of backtick x backtick rounded to the nearest 2 decimals is backtick r space round x 2. You're going to see this. The value of x, so x here, backtick x here. There was no r preceding it, so it just shows as code font. It doesn't run the code. Rounded to the nearest 2 decimals is 8.77. This because what it did is it took the square root of 77, rounded it to 2 decimal places, and then inserted in the document seamlessly. So the inserting of the document, like the inline code here, again, works like this. And if you want, you can just refer to things you created in a chunk. So if you're not comfortable writing out a big R statement in here, you could just call on an object you've made elsewhere and insert it if you want. Okay, makes sense. Toy with it, play with it. It ends up being pretty neat. If you go wild with it, it can be really powerful for documents that have to be rerun all the time. Okay, so this is amazing. This is something I legitimately think is amazing. And when I first saw it, like 10 years ago now almost, it blew my mind, okay? So having R dump these values straight into the document protects you from silly, stupid mistakes. And yes, it pulls objects for the environment, but it specifically pulls them from the Markdown documents environment, not your global one. It can only call on things created in the R Markdown document. Yeah, great question. So think about this. Never wonder, how did I come up with a quantity ever again? If you have something written in a journal article, actually had this happen to me. I hard-coded a number in a journal article, and I got back and I couldn't figure out where the number came from. So I didn't know if the table one was wrong, the text one was wrong. Well, if I had done this properly, you'd never wonder because you can see literally where it's being pulled out of. Nothing is coming out of the ether. You're all calling it from an actual calculation. This is also consistency. You never have to do a find and replace of something through an entire document. If you're referencing this variable in line throughout it, if things change or update, all your values have updated for you too. You don't have to recalculate stuff. If you're doing things like reporting sample sizes and things, it takes care of it for you. You don't got to worry about it. It makes your life easier. A little bit of upfront work makes life later much easier. Okay, another thing. You are way more likely to make a typo hard writing out numbers and tables and stuff than to write R code that somehow gives you the wrong value yet doesn't give you an error. Okay, tables and stuff, you're very unlikely to find a way to code your R table and get one value wrong in a table. But if you're doing them manually, honestly, I have never entered an entire table of data into like Word without making at least one mistake. R will save you from that problem. Okay. This is an example I'm going to skip over for time, but if you want to know how to make your R Markdown documents change their date up to whatever it was when it was rendered, you can steal this code from my slide. My slides on the very first slide say when they were last updated because they literally have this code embedded instead of a date entry in the YAML header. You steal this, copy and paste it in there, it will update it on the fly. I'm not going to dwell on what this says here, though. I'm just going to go past it. Okay, so one of the last things I want to talk about, with too little time to talk about it, is data frames. So in the sample R Markdown doc that you're working on, we can load in a built-in data frame called cars. If you type in cars or something, it will display a simple data frame about cars. Cars is a data frame. It's an object type I talked about earlier, which is basically like a spreadsheet. If we want to look at it, we can look at it a few different ways. So if you do data cars, either in your script thing, run it in a chunk, or run it in your console, this will load the data frame into your global environment. If you do data cars and run it, in your environment in the top right, you'll see cars appear. It's going to appear a little weird at first. It's going to appear as something called a promise. That's R's way of saying, I promise the data are there, but I'm not going to actually load them until you ask me to use it. Lazy evaluation. If you say view with a capital V, view cars, it will pop up an interactive viewer pane. It's not interactive in a way of being able to change values. It's interactive in the way that you can browse around. Okay. This will bring up a viewer pane. You can look around in a data set. This is kind of like state as viewer, but with no editing capability. Okay. Another thing you can do is in your console or something, getting an error. Attempt to use zero length variable name. So most likely you knit your R Markdown document and your chunk header is slightly messed up in some way. Make sure it's 3 backticks, squiggly bracket, R, close squiggly bracket, next line. And make sure you're in an R Markdown document and not a syntax document. Let me know if not at the end. So for the first homework, should we use built-in data or be given a data set? You'll be given a data set. I'm going to talk about it in a second. It's Swiss. Okay. So if you want to display a data frame, we can say head cars 5. This will print the first 5 rows of a data frame. Head says, give me the first n elements of an object. The first 5 elements of cars are the first 5 rows. Okay. So head is a useful function. Use it all the time to glance at objects. Okay. Other thing you can use to quickly look at an object, str displays the structure of an object. If I say str cars, it will say cars is a data frame with 50 observations of 2 variables. Those variables are speed and distance, which are numeric variables, and their first so many values are these for each variable. Structure is a quick way to get a glance at a data frame or something. It's another useful way to look at something. The more data you have in a data frame, the more useful something like structure gets, because you don't want to just dump a head out of a data frame. Structure becomes handy for this. We'll talk about another one later in the term called glimpse. Okay, summary I showed you earlier. Summary will give you some basic summary statistics of a data frame. The speed variable has a minimum of this, a maximum of this, a mean of this, distance, same thing. A thing about R, using summary on different types of objects gives you different results. This is because R is an object-oriented programming language and it behaves differently with different objects. Over time, you'll intuitively begin to understand what summary will give you with different object types, but I'm not going to dwell on it for now. Just know that usually doing summary on an object will give you some sort of useful information, but it might be a magical mystery what's going to pop out before you run it. Okay. We can generate ugly pictures. So it looks like given the amount of time we have, I'm probably going to go about 4 minutes over. If you do have to jet, always feel free in this class to leave whenever you want. Your time is valuable and you know how to prioritize it better than me. But if you don't mind, I'm going to go about slightly over time. There's also recordings too. So we can generate some ugly pictures of this data frame we just pulled down. So cars, the built-in data frame, we can generate histograms. So if I say here, I would like a histogram of the cars data frame, specifically the speed variable, I will get a histogram of this. This $sign here is referred to as the extraction operator. It is a way to subset data in a data frame or list. This says, I'm going to start with this data frame. I'm going to extract from that data frame the speed variable or column. Okay? So you can use $sign to get by name a column out of a data frame. We're going to use this a lot more on later. You'll see other examples of it. But just know in R, because you can have multiple data sets loaded, if you want to call in a variable like speed, you have to tell it what data frame to look in. This is unlike state or something where you can only load one data set, so you only have to call the variable name. Here, you got to be like, it's in the car's data frame, and speed is what I want out of that data frame. Okay, so I could do a histogram of a variable like this, a histogram of another one. Histogram takes a vector as an input. A single column of a data frame is a vector, and so it can convert it into a histogram. We will never again do histograms this way in this class because I'm going to show you a better graphic subsystem next week, but this is how you could do some ugly pictures. We might be able to modify these slightly. I could say something like, take my histogram of distance, but give it a nicer X label. Here I say the X label should be distance in feet. The main title should be observed stopping distance of cars. It's the same plot from the last slide, but now it says observed stopping distance of cars and distance in feet. Everything else is the same. These are additional arguments to the histogram function, which lets you modify the way it looks. Again, don't have to memorize these things, but just know that typically with plots and things, you can just add additional arguments that will modify how they look. With base R plots like this, it all tends to be done in one big function call. Okay. Other things we might want to do is some basic math with the cars data. So if I say something like, I want to calculate the mean of cars $distance and assign it to distance mean, what this will do is it will extract that vector. So it takes the cars data frame and then pulls out the distance variable and then calculates the mean of it, the arithmetic average, and assigns it to distance mean. This is 42.98. A handy markdown trick, if you're interested, or a handy R trick. If you do a calculation with an assignment like this, normally it won't show you the output from it, but if you put some extra parentheses around it, it will display what it did as well as making the assignment to the object. Handy dandy trick. I use it in my slides to save space. I then also get the mean of the speed variable and assign it to speed mean. Okay, so I use this in something else. I'm going to say here, I want to do a plot of distance on speed. This object here is something referred to as a formula in R. This is the vertical axis of the plot. The tilde says I want it to depend on this thing over here. So y depends on x. You can make regression formulas like this too. This would be like y is regressed on x. I want to plot using the cars data set. This is a different way of doing a plot like we did before. It knows if I say data equals cars, where to find distance and speed is going to look in the cars data set. I do here a nice X label, a Y label, a main title. PCH makes the dots a little bigger. Then I add some other things to the plot. AB line makes a horizontal line at the mean of distance. AB line V makes a vertical line at the mean of speed. I make this one fire brick red and this cornflower blue. And now we have a scatter plot with some vertical and horizontal lines through them. I'm just showing this as an example of how you could take base R graphics, build them up, and make them look not like hot burning garbage. But this is not the way that we're going to generate graphics in this class. But for this first homework, if you want to make a plot, steal code like this, modify it for the data set we're going to work with, and that will be sufficient for where I ask you to make a plot. Okay, so this is an example. I could explain more on this stuff, but it's better to tinker with it, watch it break, and try and unbreak it and get a feel for how it works. Okay, so this data set you're going to use in your homework is called Swiss. So I'm going to show you the Swiss data frame a little bit to familiarize you with it. It's a really simple data set, and it doesn't matter too much what you do with it. You're just going to play with it. So Swiss, if you want to know what's in the Swiss data set, you can type $Swiss in the console and hit enter. Data sets in R have help files too. So if you want to know what the variables mean, look in the help file. You'll have to rely on that if you want to know more about the Swiss data set. So use this as an excuse to browse through a very user-friendly help file. Okay. If you want to load the data into your global environment, you can say data Swiss. It will appear in the top right global environment. Then you have access to it. Technically speaking, it's a built-in data frame. You don't even have to load it to have access. If you just typed Swiss without doing data Swiss, it would still show you the data frame. But if you want to show it in your global environment, you do data Swiss. Okay. Okay. So what I want you to do for this homework is basically you're just going to add some chunks to one of those R Markdowns. So delete all the R Markdown stuff that's in there. Leave the YAML header, but just delete all the other filler stuff. And then write some text. Write some R Markdown chunks, experiment with some things, and talk about the Swiss data set. It's going to be very basic. On the last slide, I'm going to show you exactly what I expect. It's really not very much, and I don't want you to spend hours on any of these early homeworks, especially in later homeworks. I really don't want you to just like bash your face against it. Still, it'll be simple. Might experiment with things like plots, tables, stuff like that. Okay, so if you look at the Swiss data set, this is an example of a plot you could have in your homework, or it's just a useful plot to know about. This is a pairs scatter plot. If I say pairs, a data set, technically that's all I got to do. What it's going to do is it's going to generate pairwise scatter plots of something. So this pane right here, for instance, is a scatter plot with agriculture on the y-axis, examination on the x-axis, and then all the data points are a scatter plot of that. If you have a relatively tame data set, not a lot of observations, A pairwise scatter plot lets you really quickly see relationships between variables. Once you get like hundreds of thousands of observations, this thing will just be a cloud of black stuff. It'll be kind of useless. But for small data sets like this, you could see, for instance, there's a pretty linear relationship between agriculture and examination. Other things kind of have weird, cloudy relationships and stuff. This is a pairwise plot. You might play with this and see how it works. It's kind of a useful thing to know about. Okay. So one last thing to mention about this. In R, one of the most useful things that we have our hands can get into are packages written by other people to do stuff for us, so we don't got to do it all manually. All the good stuff in R is some pre-made functions other people wrote and put in a package. So it's really important to know how to install and use packages in R. So if you want to install a new package in R, the function is install.packages. If you say, for instance, install.packages, quotation marks are important, Pander. This will go and download a package named Pander from the central R archive network. Grab it, put it on your computer so that you can load it up and use it. I recommend grabbing Pander for this homework assignment as a package for making really simple tables. It's very good at making really bare bones tables. Not the type you put in any kind of publication, but for quick tables in a Markdown doc, it's hard to beat. Okay, so you install.packages Pander. Once you've done that, you can load it with the library command. An important thing to know is when you load a package with library, you don't have to quote the name. You could do library Pander without the quotes, but when you install packages, you got to put a quoted name. The reason is this is not an object in R. This thing right here is actually a quoted search term to tell R to go hunt for. Normally, like a search term, you'd have to quote it. Object names you use don't have to be quoted. You'll intuitively learn this over time. Okay. Once you've installed a package, you don't need to reinstall them again. You can just use them until you either move to a new R version or the package updates. This means you should never have install.packages in any R Markdown document or any R script. You install and run installation of packages in the console. Don't put them in R Markdowns. In fact, if you put install.packages in R Markdown file, it will fail to knit. They block you from installing packages in an R Markdown doc, and they get angry at you. So run installations in your console. Later on in life, you might make yourself functions that like automatically load things and things you open and stuff. Rstudio has some functionality for it. Anyway, okay, this is how Pander works. For any package in R, if you want to use the functions in it, you got to say library, the name of the package. You only got to do it once, somewhere like in the top of your document. It will load it up once per session. Then we can say, I want to take a Pander table of, say, summary of the Swiss data set. You can give it options if you want, like style equals R Markdown, split tables 120 just makes it fit in my slides nicely. This will take that output from the summary Swiss function call and instead put it in a nice table that looks good in our Markdown document. Okay. All Pander does is convert the ugly R output by default in your R Markdown to actual Markdown code so it displays nicely in a document. That's all it does. You just give something to Pander, it will spit a table out. Okay. So that's all that on Pander, I think. Oh, yeah, you could do it also with things like head. I say head Swiss 5, put it in Pander, boom, shows up here. So here's a great question. You have to load packages once per when? Basically once per session, but an R Markdown document only has access to things loaded or created inside of it. So you have to put load the package, load library inside the R Markdown document to use functions in it. Yeah. Basically, if you have a script file and you use a function from a package, have that library loaded at the top of the script or R Markdown always. That's about it. Okay, so play around with Pander. Your homework, sorry for going 10 minutes over, your R Markdown homework is just make an RMD file with some exploratory analysis of Swiss fertility. You get to decide what that looks like. I haven't given you many tools for doing that, so just do the basic stuff I've kind of talked about on slides. But if you know how to do more advanced stuff, feel free to do whatever you want, okay? For every homework in this class, you will upload both the RMD file and the HTML to Canvas. This is necessary, so the HTML is the thing we're going to look at to see, like, that is a beautiful document. They have completed everything. If things break, we need the RMD to troubleshoot the broken code. So you got to upload both, okay? So what I want you to do is just a smattering of small things and not a lot of them. Mix some inline R calculations, tables, R output, plots with some text describing it. When I say text describing it, a sentence after a chunk is enough. Don't go crazy with this stuff, but write more if you want. I've sometimes had people return like they were working in an analytics firm quality memos for these things. I'm like, that is unnecessary yet beautiful. Anyway, all I ask is you have at least one plot and one table. Do more if you want, but you don't have to. And use inline R calculations or references at least once using maybe some function like these. I haven't introduced half of these functions, so you might play with them and see what they do. The only thing I ask is don't hard code any numbers referenced in the text. If you want to say the mean of Swiss fertility is 56, I would hope not, but if that's what it is, you could hard code backtick R space mean Swiss $fertility and insert it that way into your document. That goes for the entire class. If you reference any numbers, don't hard code them, put them as inline R. All I ask is that make it semi-pleasant to work for a peer to look at, maybe use some section headers, label your plots clearly. If you want, try to use echo and results options in the chunks, but we kind of had to breeze over them, so it's okay if you don't really use them, but maybe experiment with it. Summarize any values you talk about as sentences in text, maybe round numbers if you use them in text to a couple digits. That's all I'm asking you to do. It's pretty simple. There's probably some example ones still up on the course website if you want to see. That's it. The rubric for these things are really, the only way to get a 0 is to turn nothing in. Remember, you only need 60% of the points to pass this class, and one of them is for showing up. Turned in, low effort, but you missed instructions is 1. If you made a decent effort, regardless of how well it works or anything, you will always get 2 points, which is sufficient to pass the class if you do them all with a 2. A 3 is if you did a good job. Most homeworks are going to be 3s. we're not hard graders. I should say Brian is not a hard grader. That's it. So sorry for going over time. If you got questions, hit me up. I see there's a million Slack channel notifications here. I don't know if the things I have to address, but I will check out them. If you got anything, hit me up. Otherwise, sorry for going over. I promise this class does not normally go over. I just put way too much in the lecture this time because I get excited about the first day. So I think it'll be a good time. Okay, there's a question. I'm really bad at spelling and grammar. I totally understand. Does R Markdown help with that, like in Word, if you want to write a thesis in it? Rstudio nowadays has built-in spell check. It doesn't have built-in grammar checking, but it has built-in spell checking. Yeah, so you could theoretically, and many people have written entire journal articles, theses, dissertations in R Markdown. I'm a hybrid person because I still take advantage of certain functionality in Word. I tend to write the raw text of things and the iterations of it in Word, and then migrate everything over to R Markdown once I have like a proper draft. It's just easier for me to work that way because I'm a little old school and I'm committed to Word a bit. But a lot of people I know write everything literally in Rstudio. Like, I think Kieran Healy doesn't use Rstudio, but he writes everything in our Markdown documents. This guy publishes articles all the time. He just does them all as plain text docs. Next one. Could you clarify what we're expected to do other than homework peer review? As I'm sure what homework things I should review in advance of class. You don't have to review anything in advance of class. All you have to do is homework and peer review. They're up on the course website. There are optional things if you really feel like it. Under things, there are sometimes recommended things to read that are usually bolded on the website. They're just recommendations. I don't require you to do anything. We're all adults, but I try and give you lots of stuff if you want it. So for instance, you might get something extra out of like R for Data Science, which is a really good free online textbook for learning R. You might open up this chapter and read the chapter here. If you want, you could go through their exercises. Yeah, you might do stuff like that. Oh, wow, they've updated it since the last time I looked at it. It's all nice. But that kind of thing. You're not required to do anything, and you're not tested on anything. Nah. Trying to give you as little additional work and be as efficient as possible because everyone is busy. Anything else? If not, get out of here. I'll see you folks on Monday. Where should I post questions in Slack? If it's homework related, homework is great. If it's general. And anywhere, really. I don't care. I don't even know why I got 2 channels. It's all basically the same stuff. Yeah. Quick question on ad code. What you got?
I figured I'll just unmute if that's all right. Can you hear me?
Yeah.
Okay, cool. I am the one of, or maybe the only person that's doing this as a graduate non-matriculated, and I was trying to register for the class officially today, but on the registration page, I went and used the SLN code and said something about having to have a prerequisite. I'm not sure if it would help if there was an ad code that I could try using.
Did I not send you one before?
Don't.
Let me see.
Let me see. Yeah, I should have checked that actually. I don't think so, but I could be wrong.
No, I don't think I did, but
Yeah.
if you give me approximately 6 more seconds, you should have one. Oh, I don't know why I tried to paste that one in. Okay. Oh, stupid Excel. Okay, there you go. Excel tried to paste in the entire spreadsheet, so it took me longer than that. Okay, try that one. So should get that in your email in a second.
All right, sweet. I will give it a go and let you know if I have any trouble.
Yeah.
Thanks so much. That was already more helpful than like 3 entire quarter-long classes I've taken in R. So looking forward to it. Thanks. Take care.
Okay, I'll kill the recording.